In this question, you will show how to represent a time domain signal in IQ form. In order to write the signal v of t in IQ form, you should first write the cosine term explicitly. Then, by equating this signal to the IQ form, you can extract the in-phase and quadrature components out of it. Put phi equals pi over 4 to your results from part A. See that both components are equal to each other in this case. This was expected because a shift of pi over 4 means that signal vector has equal components in in-phase and quadrature axes. The Fourier transform of the signal v(t) is directly given in the solution. You can check it by looking at the corresponding part of the Fourier transform table. A cosine with some frequency fc in time domain will duplicate and shift the signal to the minus and positive fc from this property, and some others. You are expected to find Vf. What you are asked to find is the amplitude spectrum of Vf. When taking its amplitude, note that it is a complex signal. And finally, draw this amplitude spectrum. Question: complex baseband representation. An RF pulse is defined below. Find and sketch its complex envelope and envelope. G of t equals 10 rectangle t over 10 cosine 2 pi 10,000 t plus 45 degrees. Solution: complex envelope is equal to G in phase plus J G quadrature. Envelope is found by taking the magnitude of the complex envelope. Question: bandpass signal representation, frequency domain. An RF pulse in frequency domain is defined below. Find and sketch its envelope. G of f equals rectangle f minus 10,000 over 100 plus rectangle f plus 10,000 over 100. Solution: first, transform the bandpass signal into the low-pass equivalent in frequency domain. This is done by shifting the center frequencies to 0. Then take inverse Fourier transform of this low-pass signal to get to the envelope signal A of t.